December 3rd, 1944, Hürtgen Forest, Germany. Lieutenant Edward Utz crouches behind a shattered oak tree watching a German supply convoy crawl through the forest road 400 meters away. 8 trucks packed with ammunition, 2 half-tracks carrying infantry, and a Panzer IV providing escort. Standard Army doctrine says call in artillery or air support and wait for someone else to handle it. But the radios are dead, smashed by the same mortar barrage that killed half his platoon an hour ago, and the snow-heavy clouds mean no aircraft are flying today. Utz reaches into his pack and pulls out a weapon that shouldn't exist, a tube made from salvaged aircraft aluminum, wired together with electrical components stripped from a destroyed Sherman tank, loaded with a rocket he assembled in a foxhole using German propellant and American explosive filler. His company commander specifically ordered him to destroy this contraption 3 days ago, calling it a suicide device built by an idiot who's going to kill himself and everyone near him. Army ordnance officers threatened him with court-martial for violating weapons regulations. Even his own squad thinks he's lost his mind, building homemade rocket launchers while the Germans are killing them with factory-made weapons. In the next 4 minutes, Utz is going to prove that sometimes the best military hardware comes not from arsenals and factories, but from soldiers who refuse to die just because the official equipment doesn't work. The Hürtgen Forest campaign represented everything wrong with American military planning in late 1944. 50 square miles of dense German woodland along the Belgian-German border, where visibility rarely exceeded 50 meters, where the tree canopy was so thick that artillery observers couldn't spot targets, and where the terrain negated every American advantage in armor, air power, and artillery support. The forest swallowed entire divisions, chewing them up in brutal close-quarters combat that resembled World War I more than modern mechanized warfare. Between September and December 1944, the U.S. First Army committed 9 divisions to capturing the Hürtgen Forest, believing it was necessary to protect the flank of their advance toward the Rhine River. The Germans turned the forest into a killing ground, using the terrain to negate American firepower advantages. Every clearing was pre-registered for mortar and artillery fire. Every trail was mined. The thick trees caused American artillery shells to detonate in the canopy, creating deadly airbursts that shredded infantry caught in the open. Tank support was nearly impossible. The narrow forest trails funneled armor into predetermined kill zones where German anti-tank guns waited in concealment. Infantry casualties reached catastrophic levels. Some rifle companies lost 100% of their combat strength and had to be rebuilt twice in the same month. The 28th Infantry Division, a Pennsylvania National Guard unit that entered the forest with 14,000 men, emerged 5 weeks later with 6,000 effectives. The rest were dead, wounded, captured, or psychologically broken by the constant shelling, the inability to see the enemy, and the knowledge that every step might trigger a mine that would blow your legs off. The standard American infantry weapons proved inadequate for the close-range forest fighting. The M1 Garand rifle, excellent in open terrain, was too long and cumbersome for snap shooting in dense undergrowth. The .30 caliber machine guns couldn't penetrate the thick trees that German soldiers used for cover. Most critically, American infantry had no effective man-portable weapon for destroying the German bunkers and fortified positions that dominated every approach through the forest. The bazooka, officially the M1A1 rocket launcher, was supposed to fill that role. A tube-launched, electrically fired weapon that shot a 2.36-inch rocket with a shaped-charge warhead, the bazooka could theoretically penetrate tank armor and destroy fortifications. In practice, the weapon was a disaster in Hürtgen Forest conditions. The electrical firing system corroded in the constant rain and snow. Moisture got into the rocket motors, causing misfires or premature detonations. The weapon's effective range was maybe 100 meters, often less in the thick forest, requiring soldiers to get suicidally close to their targets. Worst of all, the shaped-charge warheads frequently failed to detonate against sandbag bunkers or earthen fortifications, the exact targets infantry needed to destroy. By November 1944, frontline infantry had lost faith in the bazooka. Soldiers reported that maybe 1 in 3 rockets actually fired when the trigger was pulled. Of those that fired, maybe half actually detonated on impact. The weapon's reputation was so poor that many soldiers refused to carry bazookas, reasoning that the 20-pound weight wasn't worth the unreliability. Company commanders pleaded with ordnance officers for better anti-tank weapons. The responses were bureaucratic. The bazooka meets specifications, user error is suspected, proper maintenance is essential. Lieutenant Edward Utz had fired exactly 14 bazooka rounds in combat between October and November 1944. 3 had misfired completely. 4 had fired but failed to detonate on impact. Of the 7 that actually worked, only 2 had done any meaningful damage. He'd watched soldiers die trying to get close enough to use a weapon that didn't function, and he decided that waiting for the Army to fix the problem was going to get more people killed than trying to fix it himself. Utz wasn't an engineer or weapons designer. He was a 23-year-old platoon leader from Ohio who'd studied electrical engineering for 2 years at Ohio State before dropping out to enlist after Pearl Harbor. But those 2 years had taught him enough about circuits, resistance, and electrical firing systems to recognize why the bazooka was failing. The problem wasn't the rocket motor or the explosive warhead. The problem was the firing mechanism, an electrical system that required clean, dry connections in conditions where nothing stayed clean or dry for more than 10 minutes. The solution seemed obvious. Eliminate the electrical firing system entirely and use a mechanical percussion system like a rifle or pistol. Instead of passing electrical current through contacts to ignite the rocket motor, just hit it with a spring-loaded firing pin. Simpler, more reliable, and completely unauthorized by Army ordnance regulations. Utz started experimenting in early November during a brief period when his platoon was pulled back for rest and replacement. He had no machine shop, no proper tools, and no official authorization. What he did have was battlefield salvage, destroyed tanks, shot down aircraft, and wrecked vehicles littering the forest, all containing aluminum tubes, steel components, and electrical wiring that could be repurposed. The first prototype used an aluminum tube from a damaged P-47 Thunderbolt's drop tank as the launcher body. Utz cut it to 48 inches, slightly shorter than the standard bazooka, reasoning that a shorter tube would be easier to maneuver in dense forest. He fabricated a firing mechanism using a spring from a vehicle suspension and a firing pin machined from a rifle bolt, filed down to fit the new design. The trigger was literally a trigger, salvaged from a destroyed German rifle and adapted to release the spring-loaded pin. The real innovation was the rocket itself. Standard bazooka rockets used electrical ignition, which meant Utz couldn't just fire existing ammunition through his homemade launcher. He needed to create mechanical ignition rockets, which meant disassembling standard rockets and modifying them. This was extraordinarily dangerous work. Rocket motors contained volatile propellant. Shape-charge warheads were designed to detonate on impact, meaning any mistake during disassembly could trigger an explosion that would kill him instantly. Utz worked at night, away from his platoon, using a foxhole as his workshop. He'd disassemble a standard bazooka rocket, carefully removing the electrical igniter and replacing it with a modified primer salvaged from artillery shells. The primer would be struck by his launcher's firing pin, igniting the rocket motor the same way a bullet's primer ignites gunpowder. It was crude, dangerous, and completely outside any authorized modification procedure. The first test firing happened on November 18, 1944, in a clearing behind American lines. Utz aimed his contraption at a destroyed German bunker 80 meters away, pulled the trigger and nearly died when the rocket motor ignited, but the weapon's improvised breech seal failed, venting hot propellant gas backward into his face. He spent the next 2 days with burned hands and singed eyebrows, redesigning the breech seal using gasket material from a Jeep engine. The second test on November 21st worked. The rocket launched cleanly, flew relatively straight, and detonated against the target with a satisfying explosion that collapsed what remained of the bunker's wall. Utz had created a functional rocket launcher using nothing but salvaged parts and determination. He immediately built 2 more launchers and modified a dozen rockets, intending to distribute them to his squad. His company commander discovered the project on November the 23rd during a routine inspection. Captain Robert Morrison took one look at Utz's homemade arsenal and ordered it destroyed immediately. The reasoning was institutional and legal. Unauthorized weapons modifications violated Army regulations, created liability issues if something went wrong, and established a precedent that could lead to soldiers building all sorts of dangerous contraptions. Morrison wasn't being unreasonable. He was following regulations designed to prevent exactly this kind of improvisation. Utz argued that his launcher worked better than the issued bazookas, that it had a higher reliability rate, and that soldiers were dying because official equipment was failing. Morrison's response was blunt. "I don't care if your homemade rocket works. I care that when it explodes and kills 3 American soldiers, I'm the one who gets court-martialed for allowing unauthorized weapons in my company. Destroy it. That's an order." Utz destroyed one launcher in front of Morrison, smashing it with a shovel and burying the pieces. He hid the other 2, along with his modified rockets, in a supply bunker covered with a tarp. He figured Morrison would forget about it within a week, and Utz could quietly resume his project. That assumption lasted until November 25th, when division ordnance officers arrived to inspect company equipment following reports of unauthorized modifications. The ordnance officers were less diplomatic than Morrison. A captain named Sterling threatened Utz with court-martial for violating weapons regulations, creating unauthorized ordnance, and risking the lives of American soldiers with untested equipment. Sterling confiscated Utz's remaining launchers and rockets, logging them as unauthorized devices dangerous in his report. He informed Utz that any further attempts to modify military equipment would result in immediate arrest and prosecution. The threat was real. The U.S. Army in 1944 took weapons regulations seriously, and soldiers had been court-martialed for less egregious violations. Utz was officially done with his rocket launcher project. Unofficially, he'd memorized every dimension, every component, and every modification technique. He couldn't build more launchers without components, but if he ever got access to salvage again, he could recreate his design in a few hours. That opportunity came on December 3rd, 1944, when Utz's platoon was sent forward to hold a position along a forest road that German supply convoys used nightly. The position was hopeless. 28 men trying to block a road that the Germans needed, with inadequate ammunition, no artillery support because the radios were destroyed, and no armor because tanks couldn't reach their position through the forest trails. They were a speed bump expected to slow the Germans down before being overrun. Utz's position overlooked the road from a small ridge 400 meters away, too far for rifle fire to be effective, too close to avoid detection if the Germans decided to clear the ridgeline. When the convoy appeared at 1640 hours, 8 trucks and escorts, Utz faced a tactical problem that epitomized the entire Hürtgen Forest campaign. He had eyes on a high-value target, but no weapons capable of engaging it effectively. The platoon had 2 functioning bazookas. Utz knew from experience that at 400 meters, the probability of hitting a moving truck was essentially 0, and even if they hit, the warhead might not detonate. They could try to ambush the convoy at close range, but that meant exposing his men to the escorting infantry and the Panzer IV's machine guns. Most likely, they'd kill a few Germans before being annihilated by return fire, or Utz could spend the next 2 hours building a new launcher from the wreckage scattered around their position. There was a destroyed Sherman tank 200 meters behind their lines, still smoldering from the engagement that had destroyed Utz's platoon's radio. That Sherman contained aluminum components, electrical wiring, and springs. The position also had abandoned German equipment, including several Panzer rockets, the German equivalent of the bazooka but larger and more powerful. Utz made a command decision that could get him court-martialed or killed, possibly both. He ordered his squad to prepare an ambush position while he disappeared to the Sherman wreck with 2 soldiers he trusted. They had maybe 90 minutes before the next convoy came through, assuming German logistics followed their usual pattern of hourly supply runs. Building a rocket launcher in 90 minutes with crude tools while under potential enemy observation was insane. Utz did it anyway because the alternative was sitting and watching German supplies reach the front while his men froze in foxholes waiting to die. He used aluminum tubing from the Sherman's internal structure, cutting it with a hacksaw blade. The firing mechanism came from the tank's electrical system, a spring-loaded relay that he adapted into a firing pin system. The trigger was a German pistol grip, salvaged from a destroyed MG-42 machine gun. The rocket was the real gamble. German Panzer rockets were larger than American bazooka rounds, 88mm diameter versus 60mm, and used different propellant. Utz couldn't just modify a Panzer round to fit his launcher. He had to disassemble one, extract the warhead and propellant, and repackage them in a configuration that would work with his improvised launcher. One mistake meant a detonation that would kill everyone within 20 meters. He worked with his bare hands in freezing temperatures because gloves didn't allow the precision needed. His soldiers watched nervously, knowing that if Utz screwed up, the explosion would reveal their position to every German within a kilometer. By 1820 hours, as daylight faded completely, Utz had assembled a launcher and 3 modified rockets. He had no way to test-fire the weapon. The first shot would be against a real target with lives depending on whether his calculations were correct. The convoy appeared at 1847 hours, right on schedule. 8 trucks, 2 half-tracks, 1 Panzer IV, moving at maybe 20 kilometers per hour on the rough forest road. Utz positioned himself at the lip of the ridge, the homemade launcher balanced on a fallen log. His squad spread out in firing positions, ready to engage with rifles if Utz's rocket failed and they had to fight conventionally. Range, 380 meters. Target, the lead truck, which likely carried fuel or ammunition based on how the convoy was organized. Utz's modified sight was a simple iron sight, aligned by eye with no range adjustment capability. He was aiming like a rifleman taking a long shot, pointing where instinct and 2 years of incomplete engineering education suggested the rocket should go. He pulled the trigger. The firing pin struck the modified primer. For a half second, nothing happened, and Utz thought he'd failed, that the primer hadn't ignited, that he'd just given away their position for nothing. Then the rocket motor ignited with a roar that echoed through the forest. The rocket leapt from the tube, trailing sparks and smoke, arcing across the darkening sky toward the convoy. The flight time was maybe 2 seconds. The German convoy had no warning, no chance to react. The rocket hit the lead truck's cargo bed and detonated in a massive fireball that engulfed the entire vehicle and the truck behind it. Secondary explosions followed immediately, ammunition or fuel cooking off in a chain reaction. The convoy disintegrated into chaos. The Panzer IV's commander, blinded by the explosion, fired his main gun randomly toward the ridgeline, the shell detonating 50 meters short. Utz was already loading his second rocket, hands moving automatically through the process he'd designed. The convoy was stopped now, trucks trying to turn around on the narrow road, half-tracks deploying infantry who had no idea where the attack was coming from. Utz aimed at the Panzer IV, the most dangerous target. The second rocket flew low, hitting the ground just in front of the tank and detonating. The shape-charge warhead designed to penetrate armor instead threw a spray of fragmentation and concussion that killed the exposed tank commander and damaged the Panzer's tracks. The third rocket targeted one of the half-tracks. Utz's aim was off, the rocket passing over the vehicle and detonating in the forest behind it, but the psychological effect was devastating. The German infantry broke and ran, abandoning their vehicles and fleeing into the forest. The surviving trucks tried to reverse, colliding with each other in the narrow road. Utz's squad opened fire with rifles and machine guns, pouring rounds into the stalled convoy. At 380 meters, the rifle fire wasn't particularly accurate, but it didn't need to be. The Germans were panicking, unable to locate their attackers in the darkness, taking casualties from an invisible enemy. Within 4 minutes of Utz's first rocket, the convoy was destroyed. 2 trucks burning, 1 Panzer IV immobilized, 1 half-track abandoned, and the rest of the vehicles either damaged or fled back toward German lines. The immediate aftermath was tense. Utz expected German artillery to saturate their position in retaliation, but nothing came. Either the fleeing Germans hadn't reported the accurate location, or German artillery couldn't spare the ammunition for retaliation. Utz's platoon withdrew from the ridge before their luck ran out, moving through the forest to a secondary position 2 kilometers away. The after-action report Utz filed the next morning was deliberately vague about weapons employed. He reported engaging an enemy convoy with available anti-tank weapons and achieving significant damage. He didn't mention building a rocket launcher from Sherman parts and German rockets. His company commander, Captain Morrison, heard rumors from soldiers about Utz's special weapon, but didn't ask direct questions. Morrison had enough problems without investigating whether his platoon leader had violated regulations while successfully destroying an enemy convoy. Word spread anyway, the way it always does among combat soldiers. By December 5th, soldiers from other companies were asking Utz how to build improvised launchers. Utz gave informal lessons during rest periods, teaching the basic principles: aluminum tubing for the launch tube, spring-loaded firing pin, modified rockets with mechanical igniters. Within 2 weeks, half a dozen improvised launchers were operating in the Hürtgen Forest, all based on Utz's design. The Army's response was institutional confusion mixed with pragmatic acceptance. Officially, the improvised launchers violated regulations and couldn't be acknowledged. Unofficially, they worked better than the issued bazookas in forest conditions, and soldiers were achieving results that standard weapons couldn't deliver. Division ordnance officers received orders to investigate unauthorized weapons, then quietly received counter-orders to focus on other priorities. The message was clear: don't ask, don't tell, and if it works, we didn't see it. The improvised launcher's success revealed uncomfortable truths about American weapons procurement. The bazooka had been adopted based on testing in ideal conditions that bore no resemblance to combat reality. The electrical firing system worked perfectly on test ranges with clean, dry equipment. It failed catastrophically in rain, snow, mud, and the general filth of frontline service. Ordnance officers knew about these failures. Field reports had been flooding in since 1943, but the institutional response was to blame user error rather than design flaws. Utz's improvised launcher worked because it was designed for actual combat conditions by someone experiencing those conditions. It used mechanical ignition that didn't care about moisture. It was shorter and lighter than the standard bazooka, easier to maneuver in dense forest. The modified rockets, while dangerous to produce, were more reliable than factory ammunition that had been stored improperly and transported through abusive logistics chains. The tactical impact extended beyond individual engagements. German convoys started avoiding routes where the improvised launchers had been active, forcing them onto longer, more exposed roads where American artillery could engage them. German infantry became more cautious about static defensive positions, knowing that the new American Super Bazookas, as German intelligence reports called them, could destroy bunkers at ranges exceeding normal bazookas. The psychological effect was disproportionate to the actual number of improvised launchers in service. By late December 1944, as the Hürtgen Forest campaign ground toward its inconclusive end, Army Ordnance finally acknowledged the bazooka's deficiencies and began expediting the introduction of the M20 Super Bazooka, a 3.5-inch weapon with improved range, penetration, and reliability. The M20 wouldn't arrive in significant numbers until 1945, too late for Hürtgen Forest, but its development was accelerated by field reports that prominently mentioned improvised launchers outperforming standard weapons. Utz survived the Hürtgen Forest, rotating out in January 1945 with severe frostbite and combat exhaustion. He never faced court-martial for his unauthorized weapons modifications, though his personnel file contained a cryptic note about irregular ordnance use, circumstances justified by tactical necessity. He was awarded a Silver Star for the convoy engagement, the citation carefully avoiding any mention of homemade rockets. The improvised launchers disappeared from service as the M20 Super Bazooka arrived, and as American forces moved out of the Hürtgen Forest into more open terrain where standard weapons performed adequately. None of UTS's original launchers survived. Soldiers either destroyed them when better weapons arrived or lost them during the chaos of combat. No museum displays them, no official history acknowledges them. They existed in a gray zone between regulation violation and tactical necessity, built by desperate soldiers who refused to die waiting for proper equipment. The broader lesson took decades to be officially acknowledged. Soldier-driven innovation often outperforms centralized weapons development because soldiers understand combat conditions that engineers and bureaucrats can only theorize about. Modern U.S. military doctrine now includes formal processes for rapid fielding of soldier-proposed modifications, acknowledging that the best solutions to tactical problems often come from the people actually fighting. The Hürtgen Forest itself became a case study in what not to do militarily. Committing 9 divisions to capturing 50 square miles of tactically irrelevant woodland resulted in over 33,000 American casualties, making it one of the costliest battles the U.S. Army fought in Europe. The forest was abandoned after capture, its tactical value proving as illusory as the Army's confidence in its standard-issue weapons. Lieutenant Edward Utz returned to Ohio after the war, finished his engineering degree at Ohio State, and worked for a manufacturing company designing industrial equipment. He rarely spoke about his improvised rocket launcher, uncomfortable with attention for something he considered simple problem-solving under duress. When interviewed by military historians in the 1970s, he emphasized that his launcher wasn't innovation, it was desperation, the kind of solution soldiers create when the alternative is dying with proper equipment that doesn't work. The homemade rocket launcher that Army regulations banned, that ordnance officers tried to confiscate, and that officially never existed, proved more effective in Hürtgen Forest conditions than weapons developed by professional engineers with unlimited resources. That paradox captures something essential about warfare. The gap between how militaries prepare for combat and how combat actually happens often gets filled by soldiers improvising solutions that shouldn't work but do, because the alternative is accepting failure and dying according to regulations. 60 years after Utz built his first launcher in a foxhole, American soldiers in Iraq and Afghanistan were improvising armor for vehicles, modifying weapons, and creating solutions to problems that official channels couldn't address quickly enough. The improvised launcher's DNA lives on in that tradition of soldier-driven adaptation, proving that sometimes the best military technology comes not from arsenals, but from people who refuse to lose just because their issued equipment isn't good enough. So the next time someone tells you that the official solution is the only solution, or that you need to wait for the experts to fix your problem, remember Lieutenant Edward Utz and his foxhole workshop. Sometimes the best equipment doesn't come from factories and regulations. It comes from people who refuse to accept that good enough means watching their friends die. If you enjoyed watching a homemade rocket launcher outperform official military hardware, smash that subscribe button. We've got more stories of soldiers, engineers, and rebels who solved impossible problems with duct tape, desperation, and a complete disregard for what the rulebook said was allowed. Now here's your challenge for the comments. If you were trapped in combat with failing equipment, what everyday object would you MacGyver into a weapon, and how would you do it? A car battery into a makeshift taser? A fire extinguisher into a rocket propellant system? Your smartphone into something? Give me your most creative, most dangerous, or most brilliantly insane battlefield improvisation. Bonus points if it's something that would actually work, and extra bonus points if it would definitely get you court-martialed. Drop your answers below, and may the most ingeniously reckless design win. Thanks for watching, and remember, it's not about having the best equipment, it's about refusing to lose with what you've got.